So I thought I'd do a refrigeration video since I haven't done one in a long time, and I know that quite a few of my subscribers have been wanting me to do one. So I'm going to be upgrading a system for chilling the antifreeze for my compressed air cooler, cooler dryer thing. So the older compressor on it was this one, which runs on DC. It will be put into storage. It's not particularly powerful. It took quite a long time to chill the bucket of water, but this one's quite a bit more powerful. It's very, very old, but it's very well built. So this rather large condenser will go on it, and I'll probably put R134A or R290 inside it once it's built. We'll just have the hot gas going in the top, and then it'll come out the bottom as liquid, and then I'll put a filter dryer on there, and I'll go inside the shed now and show you what the evaporator is going to be. So here's my evaporator. I'm going to be using a flooded evaporator design. So what will be happening is the capillary tube will be going on this side, and the refrigerant will flow in through the bottom and spiral all the way up, rather than the other way of doing it where I had it going down this way. And the problem with that was if the system was under low load, there wasn't very much heat being moved, the evaporator would get very, very cold, and then liquid would just start coming back to the compressor. But I think in this way, with the refrigerant entering the evaporator here and then having to go up the way, when the system's under very low load, what will happen is the refrigerant will just sit in there boiling, and it won't do very much. It won't come back to the compressor. The other issue though that I'm thinking about is maybe oil will get stuck in the evaporator as well, but I'll just have to test it and see. So here's the progress I'm making so far. I've now got the filter dryer assembled, and what I'm doing is putting a service valve on the end there. So on one end will be the liquid from the condenser, and on the other end will be my service valve, so I can get an idea of the high side pressure. So that's all been soldered together, and the capillary tube will come out the other end there. So here's the condenser assembly as it stands just now. So hot gas will be going in the top there, and then it'll get condensed down. Then the liquid refrigerant will come out the bottom here and go through this filter dryer. Then I'm going to attach the capillary tube just to the end there, and there's my high side service valve. So basically I just need to solder on the discharge line for the compressor to the condenser, and then solder the rest of it together. Well, here's the stage I'm at now. The condenser is soldered in place, and I'm just about to complete the loop. So behind the condenser we have there the filter dryer and the high side service valve, and the capillary tube coming up here. The capillary tube is just the same one that was on the BD35F system, so I'm assuming that with this compressor being more powerful, it will be colder because it's going to be trying to force more refrigerant through the capillary tube, so there will be a greater pressure drop, so it will reach lower temperatures, which is good because I want to be able to chill various containers in there, as well as keep the compressor air cold. So that's all for tonight. Tomorrow I will do the second part of this video where I get everything all tested, filled with refrigerant, and I'll get all the antifreeze in there as well. But as for capillary tube size, it's just a case of playing about with stuff mostly. Get different selections, see what works, see what doesn't. It's hard for me to recommend a size because it depends entirely on the compressor that you're using and the refrigerant. So, and even the ambient temperature for which the system is designed. There's so many variables. So there are programs you can find online which can help calculate. CCOP cap cell is a good one. That's what I'd use. But to be honest with you, I don't even know what size of capillary tube is on this. It's come off an old system, so it could be anything really, but it's very small and very thin, so it should be able to reach a very low temperature. But the downside to that is it's not going to be able to move heat as fast. So I'll be back tomorrow with getting this all set up.